Okay, so today I'm going to go over Module 11.1, Radical Expressions and Rational Exponents, and I am on page 533. So let's read what we're going over today. So defining rational exponents in terms of roots. Remember that a number a is the nth root of a number b if a to the power of n equals b. As you know, a square root is indicated by this radical, and a cube root by this radical with an index of 3. In general, the nth root of a real number a is indicated by the radical with an index of n, where n is the index, so that's something we need to know. I'm actually going to highlight it there and there. Where n is the index of a radical, and a is the radicand. So what's inside is called the radicand. Note that when a number has more than one real root, the radical sign indicates only the principal or positive root. So a rational exponent, let's highlight that, is an exponent that can be expressed as m over n. So basically a rational exponent can be represented in a fraction as m over n. Where m is an integer and n is a natural number, you can use the definition of root and properties of equality and exponents to explore how to express roots using radical exponents. So what they're basically saying is that you can express radicals as rational exponents. And so we're going to see that here in example A. So how can you express a square root using an exponent? This is what we're going to be doing here. So what is m? So if I have the square root of a equals a to the m, what is m? What number does m have to be? So in order to do that, you would square both sides, right? We're going to solve for a here. So we're going to square both sides, and then with our square root and our square, we get just a on this side. And over here, we get m times 2, which is 2m. And so over here, don't forget that your power is a 1, and so that's what we have here. And now the bases are the same, so the exponents have to be equivalent. So if I have a to the first equals a to the 2m, I know that 1 has to equal 2m. Right? Our bases are identical, so I can set my exponents equal to each other. And so when I do this, and I solve for m, I get that m equals 1/2. So the radical of a, or the square root of a, I should say, is a to the 1/2 power. Okay. How can you express the cube root using exponents? So we're going to kind of do the same thing we just did, only now we have a cube root, so we're going to cube both sides. And the cube root and the cube are going to cancel and give me a here. And here I have a, and m times 3 is 3m. And now, since my bases are identical, remember I can set my exponents, which is a 1, and my exponent, which is a 3m, set equal to each other. And then I'm going to divide, and I get m equals 1/3. So I'm going to flip to page 534 and finish this here. So I kind of did this work on the other page where we took 1 and 3m and set them equal to each other. And then, since the bases were the same, we went ahead and solved this. And we got m equals 1/3. So we can say that the cube root of a is equal to a to the 1/3. So let's just show you this. We could say the square root of x is equal to x to the 1/2, and the cube root of x is equal to x to the power of 1/3. Okay, I'm going to do the reflect here. It says, examine the reasoning in step A and B. Can you apply the same reasoning to any nth root? So I have the nth root of a, where n is a natural number. Explain, what can you conclude? So it worked for when your index was a 2, it worked for when your index was a 3. Will it work if your index is an n? So let's go ahead and see that. So I have, oh, let me make sure I set it up the same way they did. Okay, perfect. So I'm setting up my nth root equal to a to the m on my reflect. And now if I were to raise both sides to the nth power, I would get a equals a to the mn. Remember, this is an exponent of 1, and so I can set those exponents equal 1 equals mn, and I'm solving for m, so if I'm solving for n, I divide by n, and I get that m equals 1 over n. Okay, so that's saying any nth root can be written as a to the 1 nth. Let me make that a little bit neater. So, you know, any number here, let's say it's a 5. So the 5th root of x is x to the 1/5 power.